All right, guys, so this is going to be your next set of notes on probability. 7.3 is going to be theoretical versus experimental probability. This is something that you have learned in the past or should have. It's actually pretty basic. Your theoretical probability is what should happen. That is your short, sweet definition. What should happen. Theoretically, based on the odds, this is what should happen. So the example I have here is if you flip a coin 20 times. Well, there are two sides. There's a heads and a tails. So theoretically, because there are two sides, if you flip it 20 times, you should get heads 10 times and tails the other 10 times, making a total of 20. So your theoretical probability works out. Then what we want to do is we want to make this your total possible outcome, what happens versus your total amount of times that this experiment happened. So we have 10 out of 20 should be heads. Of course, we've learned since elementary school, always simplify these fractions. This will go to 1/2. If they ask you for a decimal, we know divide the top by the bottom, we're going to get 0.5. If they ask for a percentage, we move that decimal place twice to the right, making it 50%. So then the exact same thing will wind up happening for tails here. If we have 10, it would be 10 out of 20, giving us our 1/2, still a 0.5 or 50%. That is in theory. You're not actually doing the experiment based on the information. What should happen? Your experimental probability is now where you go and you do the experiment. So your experimental probability is what actually happens. Now you're going to take a coin and you're going to flip it. We're not really going to do that, okay? Especially since it's done 20 times, we're trying to make the video short. So let's say we flip our coin 20 times, okay? So we're going to do the exact same thing as before. We're going to flip this 20 times. What ends up happening this time during our actual experiment, actually performing the experiment, we wind up with our heads and our tails. Right? Our heads, let's say we wind up flipping heads 14 times. So if I want to know the experimental probability of getting heads the next time around, all we need to do is take how many times we flip the heads, 14, over the total number of times, which is that 20. This fraction will simplify down to 7/10. So if I wanted it as a fraction, it would be 7/10. If I wanted it as a decimal, it would be 0.7. As a percentage, 70%. So then our tails, the only amount left over is going to be 6. So let's say this was our 6 times. So again, we take the total amount that we did tails over the total amount that we flipped the coin, 6 out of 20. This simplifies to 3/10, because this is 0.3, or our 30%. And then when you add those two percentages up, you get that 100%. Okay? So the first example that we were going to go over, I already have it written out, I'll need you to write it down, is going to be, out of the last 15 cars a dealership sold, 6 were blue. What is the experimental probability the next one sold will be blue? Go ahead and copy that down, pause, and then we'll go through it. So what we're looking for here is the probability of the next one in this experiment. According to this data, 6 of the last 15 were blue. So let's see, we need our blue over the total amount. So what we have here is, how many did we sell that were blue? 6. How many total cars did we sell? 15. Guys, we simplify that down. Both are divisible by 3. We're going to wind up with 2/5, which then will simplify into 0.4 as a decimal, or 40%. That's all it is. You're done. There's your answer in 3 different forms. Okay. The next one, we're going to look at a table. Our experiment. Example number 2. Abby took a poll at school on favorite sports and recorded the data. what is the experimental probability the next student will choose baseball? So make sure we pause, copy it all down, and here's all the data. Make sure we copy all that down. Use colors if you'd like to. So again, on this, we're looking for the experimental probability. This is the experiment that Abby actually performed. And out of this, we found out we want the next what's the experimental probability the next student will choose baseball. So we're going to take all the baseball over the total amount of students that were surveyed. So here, we look over here and we see that we had 9 students chose baseball. So now our total, we need to go and we need to add all of these up. And if you add all these up, 7 and 9 will give you 16. Add another 10 is 26. Add another 7, you're going to wind up with 33. So again, this will simplify down. Both these are divisible, ironically, by 3. Again, this will wind up, your answer will be 3/11. We're just going to leave this one as a fraction because it does come out to weird decimals and percentages. And ladies and gentlemen, that's it. That's all it is for theoretical and experimental probability.